In this video, we're going to review several properties of fluids. The first property that we will review is the density. Density is mass per unit volume. And we denote this with the Greek symbol rho. This is the lowercase rho. And density, of course, is defined as your mass per unit volume. And here, this is capital V with the cross mark through it indicates that it is volume. The dimensions of density here are mass per length cubed. And one note about the density of liquids varies little with pressure and temperature. For example, you can look at table B1 and table B2 in your textbook, which show how the density of water varies with temperature and pressure. However, the density of gases varies greatly with pressure and temperature. And so, for example, you can go look at table B3 and B4 in your textbook to look at how the density of air changes with different pressures and temperatures. So that's our first property, density. Our second property that we're going to look at is the specific weight. Now, specific weight is the weight per unit volume. So density is the mass per unit volume. Specific weight is the weight per unit volume. And this is denoted by this lowercase Greek letter gamma. Gamma is equal to the density of the fluid times gravity, and the dimensions of specific weight are force per length cubed. So, for example, you'd have some weight, perhaps in newtons, per volume, so force per length cubed. Now, how do we get this equation for specific weight being equal to rho g? Well, if we just look at the definition here, we said that gamma, the specific weight, is equal to some weight divided by a volume. Well, weight we can write out as mass times the acceleration of gravity. Volume we have in the denominator, and then we can rewrite volume using the equation for density as mass divided by density here. So density is just mass per unit volume, so volume is mass per density. So the masses cancel out, and we're just left with rho g. So that's how we get our equation for specific weight. And this is a very common combination of variables, rho and g, and so we've given it its own name, the specific weight. So that's our second property that we're reviewing. The third property here is called the specific gravity. And it's very common for students to get the specific weight and specific gravity confused, so it's important that you know the difference between these. So the specific gravity is a ratio. It's the ratio of the density of a fluid to the density of water at 4 degrees C. So specific gravity is usually abbreviated just as SG, and because it's a ratio, it is dimensionless. And so the formula here for specific gravity is just going to be Sg is equal to the density of the fluid divided by the density of water at 4 degrees C. So what is the density of water at 4 degrees C? Well, the density of water at 4 degrees C is equal to 1,000 kilograms per meter cubed. Nice round number there. Or 1.94 slugs per foot cubed if you're working in the BGS system. First is, of course, the SI system. Or 62.4 pounds mass per foot cubed in the English engineering system. So what do we use specific gravity for? So this is very useful. One of the ways that we use it is to tell if a particular fluid, is denser or lighter than water. So will that fluid float on or sink in water? So specific gravity tells if a fluid floats or sinks on water. So it's a nice shorthand to tell if something is less dense or more dense than water, because it is ratio. And so instead of specifying the density, you can just say, oh, the specific gravity is this amount. So for example, we'll do a quick example here. We can say that the specific gravity of gasoline is 0.74. And so we want to find what is density in both kilograms per meter cubed and in pounds mass per foot cubed. So here we just go back to our equation for specific gravity. We say that equal to 0.74. And we know that that's equal to the ratio between the density of the gasoline and the density of water. And we know what the density of water is, so we can just plug that into the denominator. We have 1,000 kilograms per meter cubed. And so that's for the SI system, and then we'll just make that equivalent here to the English engineering units too, so 62.4 pounds mass per foot cubed. And then for each of those, we can solve for the density of gas. So the density of gas is 740 kilograms per meter cubed, or 46.2 pounds mass per foot cubed. So this tells us, of course, that gasoline floats on top of water. Also, things like crude oil have a specific gravity of about the same amount. So that tells you that crude oil will float on top of water as well. So there we've reviewed 3 properties of fluids: the density, the specific weight, and the specific gravity.